Hey everybody, this is Mr. Walsh, and today we're going to be looking at the final stations review. This isn't the last one. I mean, it is the last one, but it's the final exam review done in the stations. So let's take a look here at Station 1. Station 1 has everything to do with Unit 3 and molecules, so let's take a look here. Okay, so we're trying to determine how many valence electrons each of these atoms have. We determine valence electrons by what group number it's in, so we'll remind you of that. And so we look at aluminum, and aluminum's group number is right here, 13, so that's going to be a 3. And then sodium is in group 1. Okay. Fluorine is in group 17, so that's a 7. Beryllium is over here in group 2, so that's a 2. Neon is in group 18, so put that as an 8. Magnesium is right under beryllium. Okay, so that's group 2. Helium, that's the exception. Helium only has 2 valence electrons. Okay, so remember hydrogen here 1, right? 1, and then helium is 2, and then chlorine is here right under fluorine, so that's going to be 7. Okay, so what do the dots represent on a Lewis structure? Dots represent electrons. Okay. And then it says, decide if the properties below describe ionic or covalent. This is straight from the lab that we did. Okay, ionic compounds have a high melting point, and so if this is one, then the other one must be for the other one. So ionic is high, covalent is low. Conducts electricity is ionic, non-conductor is covalent. And then the last one is going to be a math problem. This is the ideal, the combined gas law. It says a sample of gas occupies a volume of, so we're going to do V1 equals 5 liters. Pressure is 750 millimeters of mercury. What is the volume of the pressure increase? So P2 is equal to 1,000 millimeters of mercury. And we want to know what the volume is. Okay, and notice here it says the temperature remains constant. So when the temperature remains constant, we don't worry about that. So we end up with P1 V1 equals P2 V2. And so that's 750 times 5 equals 1,000 times V2. So we divide each side by 1,000, divide each side by 1,000, and we get V2 equals, and so now we can plug that in. So we have 750 times 5 divided by 1,000. And that equals 375. 375 equals V2. Sorry, that's 3.75. Make sure I have that correct. And that unit is liters. Okay, so Station 2 is review of Unit 4, which is calculating things that have to do with the mole. And the biggest thing that we have to do is calculate molar mass. Okay, so let's do this. So we're going to have, to calculate the molar mass, we're going to have N and O. This is 2 times, and we have to use the periodic table. This periodic table says 14.007. This is 5 times 15.999. Take those and multiply that. We multiply and then add them up. Okay, so this is going to be 28.0 this is going to be 31.998. We add those up. Okay. 28.014. Make sure I plus, make sure I add those right. This is, okay. Make sure I multiply 2. 5 times 15 is not 31. Okay. That's going to be 79.995. Sorry. Okay. 79.995. We get 108.009. 108.009 grams equals 1 mole. Okay. Now NaCl. So we have NaCl. This is 1 times, we look at the periodic table, 22.99. Chlorine is 1 times 35.453. And we take those and we multiply and add them up. And we get 22.99 plus 35.453 is 58.443. 3 grams equals 1 mole. Okay, and then the last one here, CHBr. This is 2 times 12.011, and this is 5 times 1.008. And then Br, when there's no number, we say that that's 1, and Br 79.904. Okay, so then we add those up, multiply them, and then add them up. Okay, and this is 108.964. 108.964. That's grams equals 1 mole. Okay, and then we're going to use this. We're going to use the molar masses that we just found to calculate this. Okay, so remember, X line. We start with the number in the problem, 15.7 grams. We X line, grams on the bottom, moles on the top, 1 mole, 108.009, and we do that math. Okay, so we do 15.7 times 1 divided by 108.009. We get 0.145 grams, moles, sorry. Okay. So now we do the same thing. Start with the number in the problem with the unit, mole. We set up our X line, mole on the bottom, gram on the top. Okay, so 1 mole to grams, 58.443. Now we do that math. 2.5 times 58.443 is 146.1 grams. 146. Okay, and then 0.5 moles, X line, mole on the bottom, gram on top, 1 mole, 108.964. And so now we're going to do 0.5 times 108.964. It's 54.482 grams, and there's that. Okay, and now the last two. Okay. now we're going to use 22.4 liters in our X line. So this is 1.7 moles. And so look, it says how many liters. Okay, X line, moles on the bottom, liters on the top. For every 1 mole, we have 22.4 liters. And so now we do the math. 1.7 times 22.4. We get 38.08 liters. Okay. Same thing here, 40 liters, X line. We put liters on the bottom, moles on the top. 1 mole is 22.4 liters. And now we're going to do 40 divided by 22.4. We get 1.79. 1.79 moles. Okay, so that's a lot of math, but we did it. We did the right stuff there. For this one, we have to balance, and we have to determine what kind of reaction this is. Okay, so balancing. Okay, there's 2 here. Let's see, split this. So for N, there's 2, N in here is 1, so we're going to multiply that by 2. And now for H, 2 times 3 is 6. H, have to put a 3 there, so that's 6, balanced. Okay. This, we have 2 reactants going to 1 product, so 2 goes to 1. That's going to be a synthesis reaction. Okay, so now we're going to keep that KCl together. This is O2, so to get O2 equal to 3 O's, I'm going to put a 3 here and a 2 there. So that's going to be 6, that's going to be 6. And then this is then going to be, let's see, 2 KCl's. Right. Okay. So now here, what I know to do first is balance the oxygens. 2. You could still balance the silvers first, but let's see, if I balance that, I get a 2. This is going to be a 4. That's balanced. Oh, let me go back. This, just so you know, is a decomposition. And this is a decomposition reaction. Okay. Okay, so now combustion. We balanced this particular reaction 1,000,000 times. So we have 3, we're going to put a 3 here. We have 8 H's, 2 here, so we're going to put a 4 here. And so that's, for O's, that's 6 plus 4, which is 10, so we have to put a 5 there. Okay. So we're going to put a 2 here to balance the chlorines. Okay. And so we balance the chlorines. I think everything else is, oh, we need to put a 2 here. Okay. So just so you know, this is combustion, and this is an acid-base reaction. Okay, and then the last one. Let's balance oxygen. Okay, I'll put a 3 here, or let's balance this last one. To do that, you have to put a 3 here. Okay. Actually, we're going to put a 2 here because we need 2, and so now we need to put a 6 here. And so that's going to be, for this, you're going to have Na is 12. And then here, we don't want to change this number, so we're going to have 1 plus 2 NAs. We don't want to change this, so we're going to put a 10 here to get this up to 12. So it's 10, 2, 6, 1. And this is a single replacement reaction. Go back around and we start doing stuff from Unit 3 again. And so HBr, we're going to put Br in the middle, connect it with H, just so you know this is 8. So then we complete the octet. Okay. Here, when we count, we get up to 26. Okay. So we start with the central atom, we connect, make the skeleton. Okay, so we're 20, complete the octet of the exteriors. Okay, so that's minus 18, we're down to 2, put the extras around the central. Okay, so CCl4, same thing. Here we have 32, so we're going to put a C, Cl, 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 Cl. So that's minus 8. So we're 24, 2, 6, 6, 6, 6. Good, done. Okay. And now for SF2. So this is 6 plus 2 plus 7 plus 7, so that's 20. So we'll put S in the middle, F, F minus 4 is 16, 2, 4, 6, 8, 10, 12, 7 minus 12, 4 left, extras go around the central atom. Okay, CO2, that's 4 plus 6 plus 6, so that's 16 electrons, we're going to go C, O, O, so that's 12 left, we're going to go 2, 4, 6, 8, 10, 12. So we have none left, but there's no octet around the central atom, so we have to take 2 of these and 2 of these and make a double bond on each side. And then last, we have Pi3. Okay. Pi3, we're going to put P, so that's 26 electrons, we're going to put P, I, and so that's minus 6, so that's 20, we're going to 2, 4, 6, 8, 10, 12, 14, 16, 18, so we have 2 left over, and that goes around the central atom. Okay, so polar, remember there's 2 properties, there's 2 things that something has to be in order to be polar. So it has to be bonded to 2 different things, and there has to be dots on the central atom. Okay, so what I mean by bonded to 2 different things is when you have a bond, it has to have 2 different things on each side. So O and H, 2 different things, and then there's dots, so yes, this is polar. Okay, and so 2 different things, dots, so this is polar. Okay, and then this one, it's bonded to 2 different things, but there's no dots around the central atom, so this is non-polar. Okay. Determine the 3D shape. So here we have 2 bonds, and with 2 bonds, that's going to be linear. And then the B here, I guess that is B. This has 4 bonds. So when it has 4 bonds, that's tetrahedral. We got this. Okay, it says what's the molar mass of this compound? So for N, we have 2 times 14.007. O, we have 5 times 15.999. So that's 28.014. 79.995. We add those up. It seems like we may have done this already, but that's okay. 28.014 plus 79.995. You get 108.009 grams equals 1 mole. Then it says how many grams are in 1.5 moles, so we have to do an X line, 1.5 5 moles, X line, moles in the bottom, grams at the top. So we have 108.009 grams for every 1 mole. So now we do multiplication. So we're going to do answer times 1.5. And so you get, this is 162.01 grams. Okay. This compound were a gas, so 20 liters, X line. How many moles? So liters on the bottom, moles on the top. 1 mole is 22.4 liters. Okay, so now we do math again. Okay. We do 20 divided by 22.4. We get 0.89 moles. Liters cancel. Okay, so now what's the name of this compound? Okay, well, N2O5 is dinitrogen pentoxide. And is this compound ionic or covalent? It has 2 nonmetals, so this is covalent. And then we would expect this to be a gas and not a solid. Okay, remember, a gas is for covalent compounds. Okay, and so is liquid, but liquid wasn't a choice here. And then solids are for ionic compounds. Okay, here's a structure. Okay, and so we're going to try to figure out how many single, double, and triple bonds there are in this structure. So what I want to do is I want to start with single bonds, and I'm going to mark off all the ones here, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 single bonds. Okay. Then double bonds. Let's see. 1, 2, 3, 4, 5. And then this has no triple bonds. And now we want to know what the formula is. So it's going to be C something, H something. So now we're going to count. So C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C, 10. Then H, 1, 2, 3, 4, 5, 6, 7, 8. H, 8. Now we want to know what the molar mass is. So now that we have the formula, we can go C is 10 times 12.01. And 8 is, H is 8 times 1.008. And so this is 120.0.11. And this is going to be 8.064. Then we add those together and we get 128.174 grams equals 1 mole. Okay. Then it says, is this compound ionic or covalent? Well, it's 2 nonmetals. So if it's 2 nonmetals, that is a covalent compound. Covalent bonds. Okay? So there you have it. That is the final stations review. Okay? Everybody, good luck on the final, and I hope this helps out. Have a great day, everybody.